Okay, on day 3, we will be looking at the sun and the earth and how Earth's motions around the sun affect a few phenomena on Earth. So to start with, let's just take a look at the sun. The part of the sun that we see is called the photosphere. Photo means light. And the sun gives off various types of energy on the electromagnetic spectrum, but visible light, is the only thing that the human eye can pick up. The sun's surface is at extremely high temperatures, but notice how some areas are darker than others. These are called sunspots. They're darker because they are cooler. On the photosphere, the surface of the sun, you can see the gases moving due to convection, which is where heat rises and cold fluids sink. And where those gases slow down, temperature is much cooler and they appear as darker spots. If you look at the photosphere, you can also see projections or eruptions of particles. These are called solar flares. Radiation is sent from the surface of the sun. It can affect radio signals on Earth for brief periods of time, but it sends these electrically charged particles throughout the solar system. All right, the sun is made mostly of hydrogen and helium, which, if you remember from yesterday, are the same gases that comprise the nebula that our solar system came from. So what happens in the sun's core is that hydrogen fuses together to form helium, which gives off huge amounts of energy, and that's what powers all stars, not just the sun. So you can see here in this diagram, if you take a couple of hydrogen nuclei and fuse those together, as you can see right here, it's going to produce helium and give off energy. All right, so let's take a look at how the Earth moves and how it moves relative to the sun. So first of all, the Earth rotates on its axis. This is what gives us day and night. It takes 24 hours for the sun to make it around one complete rotation. So the 12 hours that it's facing the sun is daylight. The 12 hours it is facing away from the sun would be night. All right. As we are spinning on our axis, we are also revolving around the sun. Revolution is the movement of one object around another. Now, if you notice the shape of the orbit, it's not a perfect circle. It is an ellipse. And part of the time we are close to the sun, and part of our revolution we are further away from the sun. Now it takes us 365 1/4 day to make it completely around the sun. And what we do with that 1/4 of day, every 4 years we add a day on to the end of February. So on a leap year, we would have 29 days in February instead of the normal 28. Which also happens to be my birthday. So I've only had 9 birthdays. All right, another term for revolution is orbit, and that's the path that an object takes during its revolution. So all the planets orbit the sun, as well as asteroids and comets as well, and they all follow this elliptical shape. Also notice in the animation how the Earth moves more rapid when it's closer to the sun, and it slows down when it's further away. All right. Other things to notice about our orbit: when we are closest to the sun, that is known as perihelion, and that's actually in January. So we are closer to the sun in the winter than we are in the summer. So it's not the distance to the sun that causes our seasons. We'll talk about what causes seasons in just a minute. When the Earth is further away from the sun, that is called aphelion, and that occurs in July. So again, in the summertime, we are farther from the sun. When two things orbit in space, it's never one orbiting completely around another. There's actually a spot in between called the Barycenter, and it's the center of mass between two celestial bodies. So, for example, While we are revolving around the sun, the moon is also revolving around the earth. And the barycenter, or that center of mass between the earth and the moon, is actually underneath Earth's surface, about 1,700 kilometers. So you can see in the animation how the earth also orbits around that epicenter. So it's not just the moon moving around the earth. So same thing happens with any two things in space. All right, so if we look at Earth's axis that we are revolving around, the Earth's axis stays tilted at 23.5 degrees. So sometimes we're tilted towards the sun, sometimes we are tilted away. While our Earth's axis is tilted, it's also moving in a circle. This motion is called precession. It takes 26,000 years for the Earth to make a complete, or the Earth's axis to make a complete circle. So notice in the video, so if the Earth's axis had no tilt, this is what it would look like. But actually it is tilted and it is spinning in a circle, kind of like if you spin a top on the ground and the top moves in a circle. And again, that takes 26,000 years for our axis to make a complete circle. Now, the only effect that it has on Earth is that the stars that we see from the poles would be different during those 26,000 years. Right now, our axis is pointed towards the North Star, but through precession, that can change over time. But not enough. It's not fast enough that it's something you would notice in your lifetime. All right, while the Earth is moving in that precessional circle, in this direction, there's also wobbling going on. That is called nutation, and that is due to the pull of the moon's gravity on the Earth. So it only changes about a half a degree over an 18-year period. It does have a slight effect on seasons, but again, not enough that you would notice. All right, so now let's talk about seasons. So because the Earth's axis is tilted, sometimes, like in the summer, the northern hemisphere is tilted towards the sun, while the southern hemisphere is tilted away. So when it's summer in the northern hemisphere, that means it's winter in the southern hemisphere. So as we move around, notice how our axis stays oriented in the same direction, but how we are relative to the sun changes. So if we're just looking at the northern hemisphere, in the summer we're tilted towards the sun, in the winter we're tilted away. Spring and fall we are not tilted towards or away from the sun. That's why in the autumnal and vernal equinox we have equal day and equal night right along that equator. So normally the equator gets the most direct sun rays. So whichever hemisphere happens to be tilted towards the sun is going to have more direct rays, which is what gives us summer. And then the hemisphere that is tilted away has less direct rays and gives us winter. So it has nothing to do with the distance to the sun. It's our tilt towards or away from the sun.